A very good morning to all of you. I am Abu Bashar, Business Development Manager, MicroCenter Group. I heartily welcome everyone in today's webinar on solar energy in Bahrain and GCC, recent trends and way forward. Without taking much time, let me introduce our presenters for today's webinar. We have Dr. Ghulum Bakiri. He is President, MicroCenter Group. Dr. Ghulum is a widely recognized as an industry veteran and pioneer of GIS education in Bahrain. In addition to guiding the company since 1984, he was also part of senior faculty of computer science in Bahrain University for over 20 years. His BS Electrical Engineering from Austin University, USA, MS Electrical Engineering from New Jersey Institute of Technology, USA, and PhD in Artificial Intelligence and Machine Learning from Oregon State University, USA. He is also chairman of the Academic Council of Micro Training Institute and ESRI Authorized Learning Center. We have Mr. Waleed K.Alhallaj. He is BDM MENA for Jinko Solar Company Limited. Mr. Waleed has around 10 years of experience in the construction, manufacturing sectors of the photovoltaic industry around the MENA region. Waleed is a certified engineer for Energy Manager CEMC, Renewable Energy Professional REP, and Business Energy Professional BEP by AEE, where he was selected as Young Energy Professional of the year 2019 for the Middle East region. And then myself, Abu Bashar, and as I said, I'm Business Development Manager for Solar Division of Bahrain. So let us start. So this is the outline of the presentation. The keynote speech will be given by Dr. Ghulum Bakiri. After that, Mr. Waleed will talk about PV technologies and different global trends and all that. And finally, I will take little time to talk about our solar division, and then it will be followed by question and answer session. So now I invite Dr. Ghulum for going forward with his presentation.
Yes. Good morning, everybody. I'd like to welcome you all in this short presentation, and I wish that we were actually in person. That would have been much better, but I guess we will have to do with online. To start. Okay, the motivation behind this is World Bank sustainability goals. There are 17 goals adopted by the UN in 2015, and it is a universal call to end poverty and protect the planet. It covers everything from healthcare, education, and goal number 7 is affordable and clean energy, and goal number 13 is regarding climate action. And many countries have adopted their own targets for this. By 2030, all people should be enjoying peace and prosperity. And by 2050, the thing that's of concern to us is net zero emissions. Meaning that whatever we put into the air, we have to take it back in terms of balancing it with trees and greenery. Since we don't have that much space in Bahrain for that, we must focus on renewable energy. So it's a must for us. And renewable energy means solar, wind, geothermal, hydro, tidal, biomass. And since we don't have many of those, we have to concentrate on solar. Now, let me start with a personal motivation of mine that started some 30 years ago with when I built my hub, and I had a swimming pool, and a few years later, some 26 years in the thing, I was looking for solar heating for my swimming pool, and this is the system that I ordered from the US at the time, and it is a solar thermal heating. As you can see at the bottom here, we have a pump and a filter, which is normal, taking water from the swimming pool and back to the swimming pool after the filter. With the addition of solar heating, there is a three-way valve here that takes the water to the solar collector, and the blue lines are cold water. It goes through the collectors, which is nothing but, I have a control.
Yeah.
Okay. The collector is nothing but a series of pipes stacked together, very small, tiny pipes, and the water goes through it, comes out on the other side of the manifold, as you can see here. Okay, it absorbs the solar heat, transmits it to the water that's passing through the solar collectors, and comes about heated back to the swimming pool. There is an auxiliary heater if you want for cloudy days and stuff, and there is a automatic controller to control this valve, basically shutting off this at night and making sure there's no overheating and so on. So this was my original motivation, and this has been running for nearly 26 years now. It's still running. That shows you that investments in solar, whether it is thermal or photovoltaic, which we'll talk about in a moment, it is a long-term investment, so it's worth it. The second simple thing which I want to refer to here is evacuated tube solar water heaters for residential. This is a typical one, very common in the Mediterranean, and I will not go into the details of it, but basically water circulates by convection. Okay, cold water comes down, it's heated, goes back to the tank, and through this circulation, the water will get heated up. Okay. Now, when we talk about solar energy, we have to define at what level are we talking about. Is it residential that we just talked about, or is it we're talking about utility scale for governments and utilities, or is it in between for industries and commercial users? Let's focus first on the utility scale solar systems. One of them is PV solar. Go back. This is an example of a large solar array, solar panels that is used by utilities. It's PV, it's photovoltaic, so it is directly producing electrical energy by absorbing the sun rays. And I will just talk about it with one slide and leave the rest for our expert, Mr. Waleed, in the next talk. Here we have the solar panels, okay? And through combinations of series and parallel, we can get higher voltage and higher current. It goes through an inverter and a charge controller. The charge controller controls the storage battery bank here, and DC power from the battery bank or from the solar panels gets through the inverter and is converted to AC power, which is 50 hertz, 220 volts for us, or three-phase, 415 volts, 50 hertz, and it feeds into the load. Okay, not typical house or typical building or whatever. And we have also the utility coming through the meter and feeding there. So this configuration which I have shown here is called the hybrid configuration, which means that you have storage, you have the grid, and you have solar power. Okay, there are remote areas that don't have utilities, remote villages, for example. These will have off-grid, so you don't have this here. And everything is coming either from the solar or from the storage. And for many places, if you are on grid, you have the grid, you may not even require this storage. So you can work either with solar, and if there is no solar, the utility grid will feed you. And that's called on-grid. Okay, so these are the three types. This is all what we will talk about from my side on terms of PV. Okay, that was PV or photovoltaic. The other type of solar is CSP, which is concentrated solar power. Is also a thermal power. All CSP technologies use a mirror configuration to concentrate the sun's light energy onto a receiver and convert it to heat. That heat then can be used to create steam, superheated steam, to drive a steam turbine, produce electricity or electrical power, or to directly for process industries that require heat and so on. Okay, there are different technologies for CSP, and one of them is the Parabolic Trough, which you can see on the left here. And basically this is a parabolic trough, and the collector is, well, the medium goes through is here, this long tube, and it is at the focal point of the parabolic trough and receives the sunlight, heats the medium, which is usually molten salt, and so on. It goes through the rest of the system. The other technology is called heliostats. These are a huge number of mirrors that focus by the way, both of these, all CSP technologies have to track the sun. So they track the sun and focus its energy onto a receiver, which is this one, central receiver that is mounted on a tower. And the medium, which is here, is heated up, and the rest we'll talk about soon. There are other CSP technologies. One of them is linear Fresnel technology. This is basically, instead of making a parabola, they make the parabola out of long strips of straight mirrors, which are easier to manufacture. Similarly, they will track and direct the sunlight onto this receiver. Another technology is called the parabolic dish. This is nothing but a huge dish similar to the one that we use for TV reception, but it is much larger in size and also tracks the sun. The receiver is at the focal point of the dish, and it gets all the energy reflected to that and converts the medium which is there into heat. Now, these are what you saw before was schematic diagrams to show the concept. These are actual photos. This is an example of a heliostat. These huge mirrors surround this tower, which houses the receiver at the top. You can see that it's white because of all the reflections that are coming into it. This is another picture showing a similar field, and here is the receiver, and each one of these mirrors is shown at the bottom left here. And you can see that it is a very large mirror mounted on a kind of a pedestal that can rotate in various directions to track the sun and focus it onto the receiver. This is another picture, a real picture of a parabolic trough solar collector. You can see this huge parabolic shape, and in the middle here, this is the receiver, and the molten salt passes through this, gets heated, and continues either to the next trough or to the molten storage tanks, as we'll see in a moment. This is a typical diagram showing, in this case, a heliostat field, which is represented here. And here is the tower and the receiver. Okay. There are two circuits here. One is taking the cold salt. When we say cold, it is 290 degrees C. That is cold at this level. And it passes through the collector and comes back as hot to the hot salt tank. In the process, the temperature is raised to nearly 565 degrees, slightly more nowadays. This is 2015 figures. The other flow is from the hot salt tank into a series of heat exchangers and eventually back to the cold salt tank. Now, the purpose of the heat exchangers is to transfer the heat from the salt tank or the molten salt and into here, the feed water tanks that is fed through the heat exchangers, and through this process, it becomes superheated steam and is used to drive a steam turbine and connected generator to produce electricity. This here is a power block that's familiar with all utilities that have a turbine. To the next one. Now, here we see that there is a growth from 2012 to 2019. There is a steady growth in the global CSP capacity, but we are talking about 10,000 megawatts as a maximum. Here it is 6,451 megawatts, so 6 gigawatts. And if you add the coming slides to it for our region, then it will be around 10 gigawatts. Okay. Now here you can see that Spain is or was one of the leading countries in CSP, accounting for 42% of CSP at one point. It's of course it has changed since then. This is a plant in Morocco, and you can see also this is a heliostat, and this is a tower. But also you can see in the background there are trough solar collectors. So it's a combination of the two. And Morocco is also one of the countries that have invested heavily into CSP, the solar, and they are also moving into the PV. Okay, now back to our region. We have Abu Dhabi here, and this is an example of the plant in Abu Dhabi, CSP, and I think they also have PV combined in it. That started, it came into operation in 2019. We're talking about, by itself, 1.1 gigabyte in that plant. Dubai, of course, not to be outdone, has also invested into this technology, and similar plant to that in Abu Dhabi, slightly less, 950 megawatt. It has broken all kinds of records in terms of technology. You can see that here, largest single site investment, biggest capacity CSP plus PV. You can see that they are using both CSP and PV, and so on and so forth, largest area, etc. Let's move on. Now, all of these require storage. Actually, the main attraction of CSPs is the storage. You can see here when we're talking about 1 or 10 or even 100 kilowatts, we're talking about batteries, various types of batteries. Once we reach about here, 10 megawatt, then the storage will go on to molten salt and compressed air energy storage, and at very large scales you can consider pumped hydro for storage. Okay, let's go on. Now, with the plants that use both CSP and PV, you can see here, it's a similar picture to what we saw before, but we have a twist in that CSP is heating from the solars, and PV also goes through electrical heater, so the excess PV capacity heats the molten salt as well. So we can use much larger tanks for these storage tanks and produce power, okay, with storage, much larger storage than normal storage. This side here is steam generator and power curve. Okay, let's go. So this is, of course, a typical thing for utilities. They need 24/7 generation. They don't have the luxury like we do at homes that we rely on somebody else to feed the power at night. They have to generate. Now, here is a look at active plants and under development plants. You can see that almost 50% or more, they don't have storage, the active plants. Okay. By contrast, if you see the plants under development, almost all have some degree of storage, and we're talking about this orange and red with more than 10 hours and more than 13 hours of storage, so for 24/7 operations. This here is a curve I want you to concentrate on. That this is a time of day. So solar starts coming in at around 9 o'clock and it keeps on. This has this one, okay? While from here on, if you look at the green line, okay, the green line is from thermal storage. There is no generation from thermal storage until almost 6 p.m. It starts coming on and then goes almost until midnight and even beyond if you have larger storage areas. The next thing that we'll talk about here is a comparison of the levelized cost of electricity, CSP versus PV. PV is much more competitive if taken alone. But if you consider storage, then it becomes more expensive than CSP. You can see the blue is CSP, and these two are PV with 10 years battery and 15 years battery. And you can see that the costs are coming down for PV plus storage, but we still need breakthroughs in the storage in order to match the economies of the CSP, including storage. Okay, now going back to this solar energy at what level. We've talked about the utility scale. Okay, now let's talk about the commercial or industrial uses, smaller scales, like even buildings or malls. The major consumption there for the energy is air conditioning. This peaks in summer. Okay, and most commercial requirements are during the day, maybe few hours into the night, maybe until 10 p.m. or so. Solar, okay, even without storage or small storage, will be feasible. It's actually entirely feasible even for homes and personal use. For buildings, some storage is required, of course, for common areas like elevators, emergency lightings, which are a must by the civil defense, by the way. You must have generators to do that. Now you can have solar plus storage to do that. Now, one concern here will be the area requirements for the panels. And this is something that needs to be addressed. I think our friend Mr. Waleed will address that through technology called BIPV, which he will talk about. I will come by presentation or talk by going over a few promising trends which are shown in front of you. One of them is digitalization, which has the power to transform the entire energy supply chain from generation to transport, which is transmission, then distribution, and then to the consumer. And the twist to that is we now have a consumer that can also be not just a consumer, they can also be generating power, and some technology is required to meter that and so on. And we are fortunate in Bahrain that we have gone a long way in that direction with the smart grid. The other key factor here is the focus is on energy storage is becoming very well understood, and it is increasing, and it is becoming if more effective, and there are newer technologies for energy storage that will come into the picture. One of them is that with the focus on electric cars, there's a lot of research that is going into batteries, and we expect that there will be some breakthroughs there to reduce the cost of storage and increase its capacity, which will help all the solar industry, including the PV. The other one is that the new technologies that are coming into the picture with AI, with the 5G, it is enabling the decarbonization to go to the next level because of, autonomous cars, self-driving cars and drones and so on. They are removing load from the traditional fossil fuel, and it's reducing our carbon emissions and increasing the need for renewable and especially solar technologies. The final point that I want to make is about the hydrogen. Okay, there is a technological breakthrough happening at the hydrogen fuel cell level, and one of the things that we can say about this is that with the with the spread or the wide use of PV solar energy, we can use the excess PV to generate hydrogen and then use that as a renewable energy source or as a clean energy source in industries that require high power, like shipping, like airplanes, like so on and so forth. And that will be a very big step in moving to net zero emissions by the target date of 2050. And with that, I will conclude the floor to Mr. Waleed. So, Mr. Waleed, please.
Thank you. Thank you very much. Well, before I go on, I just want to make sure if everybody can write in the chat if anybody cannot see the screen because we had issues. Okay, now it is showing back.
Yes, Waleed, we can see your slide.
Perfect, perfect, perfect. Basically, it was a very interesting presentation showing that the renewable energy and basically solar energy is progressing very fast, and it is taking over the world. And this is something we have noticed in the past few years. In the past 10 years, solar energy have done outstanding steps. And basically, one interesting number is that in 2015, solar energy was responsible of 1% of the world's total electricity generation. And by 2050, which is almost 30 years from now, it is going to be responsible of 76% of the world's electricity needs. So basically, we are talking about an industry that is going to take over the world completely. And this can be shown by the growth, the massive growth in demand that we see in the market. Jinko Solar, where I work at, is the world's biggest solar module manufacturer. It is the only company in the world that has supplied over 70 gigawatt of solar modules. And basically, we have a global market share of almost 14.3%. That was there by the end of 2020. And our module capacity, yearly capacity, is 32 gigawatt for 2021. So as you can see, our module capacity for next year is almost close to being 50% of our total production in the past almost 15 years since we started. So this means that the market is very eager, very thirsty to have as much solar as possible. And basically, to be honest, something also extra from the industry, 2021 is the first year where the demand exceeds the supply of the raw material of solar modules. So basically, everybody turned to solar. People have seen how reliable this industry is, especially after the pandemic. This is an industry, these are utility projects that can operate completely automatically. It can be controlled from far. It's very reliable, and it has proved its reliability. Jinko Solar has 12 production bases all over the world. We are over 25,000 employees. Our production facilities are distributed in 4 countries: China, Vietnam, Malaysia, and the US. We have a manufacturing facility in Florida there. But basically, we supply most of our manufacturing, most of our modules from China. We have over 30 service centers, and we have 1 regional office in Dubai taking care of the Middle East and North Africa. Out of the 10 biggest markets, these are the 10 biggest markets in 2020. Out of these markets, Jinko Solar was the #1 market share leader in 7 of them. And it was the first time in history where the same company is #1 in the US, in Japan, Germany, and India all together, because these are markets that require many other things. Like the US has a huge interest and support for local products. Japan and Germany are countries that focus extremely on reliability and quality. India is a mass market. It is one of the biggest markets in the world, and it focuses on being as feasible as possible. So for one company to be able to cover all these, it is a big challenge and a great success for us. Jinko Solar is a vertically integrated solar module manufacturer. So basically, we build the wafer, we build the modules from the wafer. So we make cells out of the wafer, and then we make modules out of the cells. So basically, we can control the quality from the early point, while I think most of the other suppliers, if I may say, most of them start at the cell level or have very low wafer percentage. So basically, we produce more wafer than our modules. So we sell the rest to other companies as well. We have added 2 new products that are expected to be extremely important in the next few years. #1, the doctor mentioned the building integrated photovoltaic, which is basically adding solar modules into the building by replacing, let's say, windows in big towers and so on. And we have energy storage system, which is basically a full kit of storage that can be connected to the grid and can operate off-grid completely. But when we discuss Bahrain, Bahrain is a country that has very high availability of electricity. Basically, it is covered almost completely, and it is one of few countries around the world that produce the same amount of energy that they consume. So basically, it's an independent country, and the shift now is to secure some of the points that the doctor mentioned, and also we have reached a point where basically solar energy is becoming the cheapest way to produce electricity. As you can see from the data, these data are taken from the REN 21 report, which is an annual report that comes to discuss the energy details. So anybody can check the report for extra information. So we are talking about over 250 gigawatt of renewable energy added in 2020, and most of this energy was solar PV. So solar PV now in 2016 overtaken wind to become the most spreading renewable energy source. And basically it is because in these years solar energy became the cheapest way in the world to produce energy. In 2020, this is something very interesting. In 2020, out of all of the new additions, power plants all over the world, 83% were renewable energy sources. And again, most of this was solar. This is just to explain how fast solar energy is expanding all over the world. And basically, as you can see, the growth is becoming exponential for solar photovoltaic. This is for solar photovoltaic. So we are talking about 140 gigawatt of solar PV systems added in 2020. And by the way, 2020 was a year that was heavily affected by COVID. So it could have done much better. And basically, we expect this year the number to be around 180 gigawatt, which is a massive growth for 1 year only. This is basically why everything is happening. As you can see, solar now is becoming the cheapest way to generate electricity all over the world. This report is by Fraunhofer, which is the biggest, I think, the biggest research lab in terms of solar energy or renewable energy in general. It's in Germany, and these data are very new. So we are talking about PV, which is the utility scale. We are talking about the cheapest levelized cost of energy or electricity, as you can see. So you see numbers, you hear numbers, it's crazy. Last year in Saudi Arabia, Ribdo 2, it was closed, and the cheapest electricity in the world was also a new world record there. It was by $1 cent per kilowatt hour. And we are talking about extremely cheap electricity that can be generated of PV these days. Actually, the market is massive. And in the Middle East, basically, the market is expected to be around 10 gigawatt next year, but it is expected to be around 50 gigawatt for 2030. What Bahrain did is that it added a new 2 paths for solar energy. We have been following up Bahrain for a long time. We have supplied for the first project that was granted by the government for schools, governmental schools. We have supplied for that project as well. So we are very well familiar of the market status. And Bahrain is adding the ability to install solar energy and connect it directly to the grid. And this is very important, because you will not need to add storage or batteries at this case. You will just add your solar modules, inverter, and inject to the grid directly. So this is going to take prices down for these systems. And then you can see Bahrain started to focus on utility scale as well. We have seen some very big announcements for decent projects like the Formula One track. It is going to be the first track all over the world that is completely covered by solar energy needs completely. The entire race is going to be covered, and we expect to see much more in the upcoming years. As you know, Bahrain is very close to Saudi Arabia, and the market in Saudi Arabia is also moving, and it's moving now more than ever. We can see that the regulations are in the latest stages. The Saudi electricity company can accept now net metering or net billing applications. So basically, the entire region is upon a massive years of solar energy. Now, when you talk about solar energy, most of these projects and most of these advancements were in Europe. And discussing the Middle East has a little bit of specialty, because the weather conditions that we have are extreme, and everybody knows that. We are discussing very high temperature, and we are also discussing humidity, very high humidity. So basically, for a module to sustain in the climate of the Middle East, and let's take Bahrain, for example, for a module to sustain in Bahrain, it is extremely different from sustaining in Germany or Sweden or even the US at some parts. So it is extremely important to focus on the reliability of a module and the quality of a module in this market. And we have noticed that a lot. Even our Europe team were a little bit surprised of the very high requirements by third-party consultants for some of the biggest projects in this region. And I always take this third-party test as an example, This test is called the PQP, which is called, it stands for Product Quality Program. It is done by PVEL, which is one of the biggest labs in terms of solar energy. And what they do is that they don't believe that the IEC standard is enough. And this is their proof. They say that we can take 2 modules and we can apply the IEC requirement for them. Both of the modules are going to lose 1%. But if you add double the IEC standard, if you add a little bit more pressure on the module, one module can lose another 1% and another module can fail completely and lose 11% of its power. And this is why this lab says that the IEC standard, which is the requirement for a solar module manufacturer to sell, is not enough for harsh climate. And this is why they have replaced some of the tests for the IEC, like thermal cycling. Instead of 200 cycle, where you take the module's temperature to the minimum and then take it to the maximum, they have replaced it with 200, an additional 200, and additional 200. So a total of almost 600. For damp heat, they have added another 1,000 cycle. For the potential induced degradation, which is the PID, they have added another 96 hours of 85 Celsius and relative humidity of 85 with, so basically they have been doubling and tripling the IEC requirements in order to assure that the module is going to be in a very good condition after harsh climate conditions. And this test has a list of companies that are proven to be, we call them top performer. And basically it is based on these tests. And we are very proud to say that we are only one of 2 companies in the world where we have passed this test as a top performer every single year. And this, by the way, this test is public and it's free of charge. So anybody can go online to the website of the PVEL and you can download this test and go through the details of the test into actually very accurate detail. And there is another one, but I'm not going to go through. I think that the idea is obvious, but also for people who like to go into details, there is another very extreme test that is being done in the US now. It is called the RETC, and it takes into consideration reliability, performance, and quality all together, and only companies that pass all the 3 are registered to be a highest achiever or high achiever. And we are very proud to say that we are one of only 5 or 6, I forget the exact number, 5 or 6 companies in the world that managed to pass this test as a high achiever. So basically, a lot of details, a lot of things when it is about the durability, the reliability of a module, the quality, and it is extremely, extremely important to take this into consideration when building a project in harsh climate somewhere exactly like Bahrain. I am done, Abu Bashar. You can take over. I can stop sharing my screen and you can.
Thank you very much for this interesting information. And I will.
I'm just adding to everyone. I see some comments. If anybody has a question, I see a question or a comment from Kareem. I see many people adding comments. If you have any questions, please feel free to add it to the chat, and we're going to discuss it at the end of the presentation.
After 2 minutes, we will open the question answer session. So about MicroCenter, I think most of us are knowing in Bahrain, our group. But this has been founded in 1983, and this company is 100% Bahraini companies in the sense of employment as well as when it comes to the obligation to the country. We have 100+ people, they are working in Bahrain, and we have 5 different divisions. So like, you know, MicroCenter is more into Oracle web-based ERP solution. Then we have GIS solution. We are the sole distributor of ESRI product and services in Bahrain. Then we have our division where we are talking about the 3D modeling, LiDAR technology, then GeoBeam, and so on and so forth. We have our partners that you can see, like we are the gold partner of Oracle. We are having the silver partnership with Microsoft, and of course we are now with Jinko as well. And you see the best thing here that is Micro Training Center. That is a kind of philanthropic venture of Dr. Ghulum, in order to make the the people of this country capable enough when it comes to the competitive market. They should be ready with the latest technology, and they will be ready for the job market. So going further, this is about the product and services that we are providing under different division. So our solar division is coming into MicroCenter engineering division, where we are talking about the professional services for different varied nature of engineering services. Then we have our GIS survey, and for your information, like we are doing projects with EVA from last decades, and we have different special projects, and solar division has also been envisioned into same division. Now, like what about MicroCenter? Like we are a growing solar company, of course. We don't have much experience, but we are looking forward and we are aggressive enough to go into the end-of-end solution when it comes to solar. Either it is utility, either it is the homeowners or the malls and so on. We have started working on. And the best thing is that our team is led by our president, Dr. Ghulum, and he is an accomplished technocrat, and he is envisioning that how to revolutionize energy as far as the need of the region is concerned. And this is one of the effort of this particular webinar, where we are talking that how we can go further and how we can achieve that. So we have the people who are experienced, we have the people who are enthusiastic enough, and they want to do a kind of change when it comes to renewable energy in our region. And of course, we have all the kind of support from Jinko. So like what you need exactly is nothing, but you need a free space. That's what I want to put here. Like if you have the unutilized space basically for of course homeowners, and that like rooftop or parking areas, that can be converted into solar energy. So what is our approach, like what we are doing? So the first thing is that we are going for the energy audit, and here we are inspecting your premises. Our technical consultants are collecting all the necessary information in order to plan with you the most flexible solution that can help you and match your requirement. On the basis of this, we will try to identify the feasible scope, and on the basis of that scope, we will have the solution design. Ultimately, the installation will happen, then warranties will come into picture, and then annual maintenance system will start. And as have been mentioned by Dr. Ghulum, our annual, the solar is, most of the companies are giving 25 years of maintenance. So of course, you need to have someone who can, have the kind of capabilities that they can repair and they can manage all the kind of spares. It is like inverters or charge controllers or whatever valves are required in case of, larger installation. So we have all these capabilities, and we are looking forward to envision more and to do something in this field. So without taking much time, I will open the floor for question. So please come for the question and answer. I will request both Waleed and Dr. to answer the questions from the people. Please. They will ask.
Yeah. Yeah, go ahead. If you want to have any questions for Mr. Waleed or for me or for Bashar, go ahead.
Any reference you can give us in the Bahrain? What if you have done any installation or completed any installation?
Yes, we have done all our own buildings. There are 4 of them in Bahrain, but I think Waleed will be better placed to talk about larger installations.
Yes, as I have mentioned, there has been many installations, but none of them were as big as the ones that have been in the past, let's say, 18 months. So basically, the government decided to start by itself, and they have started by issuing a few tenders to install systems for schools. So, and I think you're going to start seeing these systems because we have started supplying, and material are arriving Bahrain now. And you're going to see some of these systems by the beginning of the new year. And there is a new tender, which is a big one for 4 megawatt almost, for the Formula One track, And it is expected to be a massive one, because basically I have seen the list of the companies that were shortlisted are all international, very well expertise companies. And I think this is usually the beginning of every market. As we have seen it in Jordan before, it starts with some international, then the market picks up, and it is 100% showing that Bahrain is going to be one of the hot market in the upcoming years.
Next question. There is a question like how to size inverters for 150 kilowatt of load.
It's a bit detailed. It's
Yeah. Okay. Any other question? If you have, any of the participants, please.
I see one question about fire. How do you manage fire on solar modules? From Zaigam. And basically, solar modules are fireproof materials, but it changes. The fireproof class changes from one type to another. And basically, if there is big issue in fire, what usually the clients ask for is a dual glass module, which is basically a module that has glass from the front and glass from the back side. And this type of modules have a fire class protection A, which is basically, there is, of course, if you go the ratings, you can read each class precisely, but A is the highest in the building overall. So basically, if there is a big problem or big issues about fire or fear from this problem, you can easily go to the dual glass modules. It's a little bit heavier in weight, but it has the exact same physical other specifications or electrical specifications in terms of efficiency, technology, and so on.
Yeah, Waleed, there is another question that is coming from Dr. Imam Al-Samad, that do you have solar powered air conditioners?
I can answer that.
Yeah, please.
Yeah, we actually have installed solar powered air conditioners in our training center in Selma 1. So you're welcome to come and see it. Yes, anybody else?
Yeah. Do we have any other question, or otherwise, like you can send us question later also through email?
Yeah, this is Murhan.
Yeah.
Murhan from Kentucky, actually. So, have you approved for these national oil companies in GCC countries? So, oil and gas companies?
The approval body for the solar is Electricity and Water Authority, I think.
Like what I meant to, so you have executed anything with them? No, any experience with oil and gas companies? They
Experience
usually
with the oil and gas company.
Yeah.
Not at the moment for us. For Jinko, I'll let Waleed answer that.
Oh.
Well, basically, oil and gas companies are usually the first adopters of renewable energy. And we can see it now all over the world. You have Shell, they have an office here focused on renewable energy. Total acquired SunPower to become one of the main players in the region. Now Total is one of the biggest developers in the Middle East region. And you can see all of these oil and gas companies are combining their facilities with solar energy, basically as simple as the fact that solar now is cheaper in terms of generating electricity and more reliable. So you can see a combination of both a lot all over the world. And the main example is the utility itself. The utility is a mixture of renewable energy and oil and gas applications.
A question
Yes,
to
thank
Waleed, if possible.
Yeah, there's a question about inverters and charge controllers and battery bank. And basically, inverters are, devices that convert DC power into AC power. And most of the time, the smaller inverters have the charge controllers built in them as well. For the larger installation, you can separate these into different ones. But we can take this question offline and answer you by email if you want. Yeah, there was also this question about the oil companies. As far as I know, for Bahrain at least, the only oil company that produces their own power is Babco. And they have something like 85 megawatts production. The rest is mostly they rely on the utility companies to supply them with power. But I know that the Tatweer Petroleum and Babco, they are using solar power for the fields, oil fields. Yes. So, I mean, they are there, we are aware of them, but I don't know that they require approvals as such.
They have their own specifications, so the company has to approach the national oil companies to get the approval. Then the contractor, like EPC contractor, so that we can easily, you will be becoming the part of the approved vendor lists. Then we can approach you, get the bidding, and then you will be participating those bigger bids. So that's the intention in this question on this actually.
Yes, thank you very much. We will definitely do that.
Yeah, thank you.
Waleed, there are a few questions in the chat box regarding the life expectancy of panel and some about inbuilt technology for panel temperature. If you can see that, please.
Yes, I see. Basically, I will to start about the inbuilt technology for panel temperature monitoring. It is very easy to add that. Inbuilt technology, there is not, and I don't think I have ever heard about any of the big suppliers, big providers all over the world. They have provided this, but to add it is extremely easy. Once you build your system and you have your monitoring system, a lot of companies build a weather station in order to calculate the performance of the station to the most efficient way. So basically what they do, they add a meter for wind speed, they add a byranometer to see what is the solar irradiation, and to add a temperature sensor is very easy on the module. So it's basically a small component that you add in the backside of the module, and you can get live feed about the temperature of a module. I have seen a lot of questions about temperature, and a lot of people a little bit worried about this and the impact, because basically temperature is the biggest enemy for solar modules, because a solar module is built out of silicon, and silicon is a semiconductor material. So once the temperature is raised, the efficiency is lowered. So a lot of people say that maybe this region is going to have a huge impact on solar modules, and it is true. This is why it is extremely important to focus on quality and reliability, because I have seen a few projects. Before I joined Jinko, I used to work in EPC. I did projects in Emirates, Saudi Arabia, Egypt, Jordan, Syria, and basically with what you see in the site is different. And it is without a doubt, heat is a big issue. And this is why you go for companies that pass the highest standards in terms of quality in order to be sure that this module is going to survive these harsh conditions. And this is what we always try to discuss all over. And also sand, I saw somebody writing something about sand. Yes, cleaning is important in our region because we are a sandy region. It has an impact. Now you can see a lot of automatic ways to clean modules like robots. A lot of people are using traditional ways, but most of the industry have added a new layer on the face of the module, which is an anti-soiling coating. So basically, if you see all these videos about nanotechnology, it is something similar where it reduces the amount of sand or soil to be gathered on the face of the module to the extreme minimum. It is called anti-soiling coating. It is usually not a standard product. If you want to get something for a project in Bahrain and you know that cleaning is going to be a problem or it's going to be a challenge, let's say, it is definitely worth it to ask that extra layer to be added on the face of the module.
Mr. Waleed, one thing when we are saying the quality control of the solar PV panel, this PQP and RETC test, the quality test, is it the standard test from the Jinko, or it need to be asked separately with the additional cost from the Jinko?
Well, it is not standard. In order to have a standard requirement, you have to provide the IEC standards, which is basically we all have, everybody in the industry have the IEC standard tests. But you don't have to pay anything extra because Jinko Solar already every year apply for this test, pay for it, and we get all the results and we are ready to share it with our clients at any time free of charge. So all of our modules that we sell have already passed this test. And if 1 year Jinko Solar does not pass the test, you can easily check the report and you will not see us as a top performer as we have been since the beginning of this test.
Yeah, okay. Yeah. So thank you very much to all of you for your time and consideration. So if you have further questions, you are welcome to send us through email. We will be responding to those questions, and we will be looking forward to see you in our other event, other webinar. Hopefully till that time we will be meeting physically. If not, then at least with other webinar. Thank you very much on the behalf of MicroCenter. Have a great day and take care. Thank you very much.
Thank you.
Thank you, Waleed. Thank you, Doctor.
Yeah, thank you all. And we'll see you in our next.